Next up on This Week in Space, Tariq and I talk about, wait for it, atomic rockets. Coming up next at the speed of fission.
Podcasts you love.
From people you trust.
This is Twit.
This episode of This Week in Space is brought to you by IT Pro TV. IT Pro TV has everything you need to level up your IT skills while you enjoy the journey. Visit itpro.tv/twit for an additional 30% off all consumer subscriptions for the lifetime of your active subscription when you use code TWIT30 at checkout. And by Blue Land. Sometimes in order to go green, you've got to get blue. Blue Land, that is. Blue Land was founded on the belief that a cleaner planet starts by reducing waste while creating powerful, effective cleaners for your entire home. Get 20% off your first order when you go to blueland.com/space. Welcome to This Week in Space. I'm your full-bodied host, Rod Pyle, and I'm joined by Tariq Malik of space.com. How are you doing, Tariq?
I'm doing well, Rod, doing well. Loving the space.
So I got a question for you, which is especially dear to my heart this week due to events in the news. So Tariq, why did the Russians never land cosmonauts on the moon?
I don't know, Rod. Why?
Because when they got there, it was full.
Wah, wah, wah. Okay, I walked into that one there. But I love it.
Okay, let me try another
I love
one.
it.
No, let me try another one.
Sure.
Why do cosmonauts drink their coffee black?
Why?
Because in space, nobody here use cream. Okay, I'm sorry. We can move right on from that. So let's go ahead and get to some headlines, shall we?
Yes, let's.
So I think first up, I had these in a different order, but I think first up, we just got to talk about the Russia thing because it's on all our minds so much, and our hearts go out to the people in Ukraine and what they're going through. But in the midst of this, we've had the ultra-patriotic Rogozin, who's in charge of Roscosmos, the Russian space program, saying all kinds of interesting things. Dmitry Rogozin. He thinks their rockets are more beautiful once they cover up the American flag.
Not just American flags, but the UK and everyone's logos.
Oh, he covered them all?
So, yeah.
So, I mean, did he paint over them or tape something on them? Because rockets go really fast when they take off, you know?
I guess it's like a decal, right? I guess you just put like another a blank decal. That's what I do when I reuse envelopes, but I guess they did it on a rocket. So a lot of drama. Yeah, you know, Dmitry Rogozin, just for old time's sake, this is the Russian official who, before taking over the space program, did tell the United States that if they wanted to get to space, the International Space Station, that NASA could use trampolines.
Right. Which is one of the favorite ones.
And this week he said that if he said that they're going to stop selling rocket engines to the United States because of the protests against Russia's Ukraine invasion, and that if we want to launch to space, they could ride on broomsticks or something.
I didn't hear that rockets. One. I like that.
Oh yeah, that was just yesterday. The tweets just keep coming. It's like a sideshow to the real tragedy that's going on in Ukraine right now. You know, and the really sad part is that, you know, these tweets aside, what we're seeing is the unraveling of a decades-long kind of global cooperation network between Russia and the other space powers of the world, and it's just very sad to see. You mentioned the covering up of the logos. That was on a Soyuz rocket that was going to carry, over 24 or 36, OneWeb internet satellites for that growing constellation. All of them are booked on Soyuz rockets, and they wanted the UK government to divest from that system and give some really crazy assurances that they won't be used for military uses. And the UK said, no, there are satellites. So now they're pulling the rocket off the pad. We don't know if they'll be able to finish their constellation. And it's just very strange, you know, that all of the ripples into space that we're seeing right now.
Well, we talked last week a little bit about their conversation about pulling out of the space station, which is an interesting one because, you know, their modules are kind of tucked in at the core of it, and I suppose they could be undocked, but there's been some conjecture that maybe they'll just pick up and leave their toys behind. Scorched Earth seems more like this guy's personality than leaving his modules behind, but we don't know. But NASA feels either way they can continue on if they have to, whereas the Russians cannot continue on without our power supply from the solar panels. So that's kind of a non-starter.
The big push comes to shove is that the Soyuz and Progress vehicles are used to reboost the station. NASA's partners with Northrop Grumman, they're going to try doing that with a Cygnus spacecraft, and I'm sure that SpaceX would find a way to do something with.
I was going to say, can't imagine Musk passing that up.
He tweeted the SpaceX logo at Rogozin to say, hey, yeah, that's how we'll do it. So.
Iron Man comes to the rescue. And just, the last thought on my end is, this is a program, the Russian program. I have to revise my estimate from last week. Last estimate I've seen is they've got a $2.9 billion budget per year, as opposed to I think at this point we're close to $24 billion, and a lot more if you add non-NASA work. And I didn't realize that Putin just last year had decided he was going to cut it 16% annually, at least through 2024. So it's not a healthy program. They've had a lot of technical problems. They've had holes drilled in their spacecraft. They had the Nauka module spinning the space station for a rotation and a half when it docked, and a lot of other problems that abort.
They blamed the NASA astronaut. They blamed the NASA astronaut for that hole in the Soyuz, by the way.
Well, yeah, because they were psychologically unstable and drilling holes to try and come home, right?
Yeah.
Didn't have a lot of evidence for that. So it's sad to watch this once very proud and great program decline, because it was in its heyday really something.
Yeah. So I'm just sad. You want to explore space together, and this just is not where I thought we would be in 2022. So.
Yeah, having lived through the space race, this kind of feels familiar, but not in a nice way. So moving on, speaking of Elon Musk, we have Starlink to the rescue. We have Elon Musk responding to a request from Ukraine to help them maintain their internet connectivity as it was being attempted to be cut by the Russians. So why don't you tell us a little bit about where that stands?
Yeah, actually, it happened really, really fast. Last week, just over the weekend, a Ukrainian official asked Elon, for any kind of help with the Starlink internet system, because they did not have reliable communications. And it seems like within days, they had a number of Starlink receivers and units on the ground in Ukraine, and it is active now. The system is up and running. They can use the system to connect not just to the internet, which is nice, but to connect to each other and have really reliable, independent communications. Now, just in the last day, Elon Musk has actually taken to cautioning the people of Ukraine using the system, saying that it does look like Elon said that it's kind of the only independent communications they have right now, and because it has a pretty unique antenna, could leave them visible to attacks, by the Russians, and so he is advising people to take care.
Because it's a transceiver, they could monitor the upcoming transmissions, right?
Exactly. That it can be detected, and that so to be careful, maybe to camouflage the transceivers. They're bright white. They used to describe them as UFOs, but they have a different shape now. Yeah. And someone even asked him, "Hey, can we paint it?" He had said maybe camouflage it with something, and Elon said that they could paint it as long as they don't use anything that has metal. Shavings or filings in it to disrupt the signal. So that's kind of the latest, a very fast response by SpaceX and the Starlink team to get that done. We saw a similar response in the Pacific after the Tonga undersea volcano eruption, where they had also asked for help. And after some work, they were able to get some units on the ground, and that service is active there too. So a very clear response plan, it seems, that Starlink has right now, and Elon Musk to be able to get this service that's still growing. They just launched a new one, a new set of rockets this week, a new set of satellites this week.
Satellites, yeah.
So it seems like they're making the most of the ability to provide remote access where it's needed.
All right, and finally, speaking of man-made objects in space where they possibly shouldn't be. How was that for a segue? We got Target Moon. We got our moon impact mystery. So I believe it was yesterday morning, wasn't it? That the
it was this morning.
Upper stage. It was this morning. The spent upper stage impacted on the far side of the moon. And we're pretty sure it was the Chinese upper stage.
That's right. That's
from
right. R.I.P.
revised
rocket.
a couple of times. Yeah.
R.I.P. rocket.
And I saw some chatter, by the way, on, I think it was on Twitter, about, we're messing up the moon and all that. And people got to understand it's basically like throwing a big empty coffee can. There's not a lot of mass to these things. They're not going to create damage. There's nothing to hit on the far side of the moon. And because it's the far side of the moon and it's been facing away from Earth for a really long time, like billions of years, it's already a mess. I mean, the far side of the moon is seriously beat up. But so we're going to be looking for that with the Lunar Reconnaissance Orbiter, right? Yeah,
I've got some details. So from what we can tell, this event happened at 7:25 a.m. Eastern time today, and this 3-ton piece of rocket junk that scientists think is from like a Chinese mission that was like a dress rehearsal for their Chang'e 5 mission. So it was from a while ago. So it crashed into a place called the Hertzsprung crater. It's a 354-mile wide crater, according to Scientific American, that is on the back. So it's a nice big crater, and hopefully, if everything goes well, NASA's Lunar Reconnaissance Orbiter will do a flyover sometime in the next few days and start looking for the crater from this impact. And the interesting thing is, apparently it's the first unplanned big impact on the moon by these things, because we've slammed stuff into the moon, or orbiters have died and they've crashed into the moon, and we expected it to happen. But this was a kind of a surprise bonus for people that are watching for that stuff.
Well, I just want to point out for the naysayers that most of us have driven cars that weighed more than this rocket stage, so it's probably not a serious thing to worry about. All right, well, let's take a break. We'll be back in a few minutes with Atomic Rockets. Stand by. This episode of This Week in Space is brought to you by IT Pro TV. Are you thinking about getting your CCNA certification? Having your CCNA shows that you're knowledgeable in networking fundamentals, IP service, security fundamentals, automation, and programmability. IT Pro TV has the classes and skills you need for everything Cisco. When I was a younger person, I wanted to work for NASA. And back in those days, if you wanted to work for NASA, you had to be an engineer or a scientist, and I didn't quite have the chops for that. But if something like IT Pro TV had been around at the time, I could have done that, and so can you. And the month of March is dedicated to Cisco at IT Pro TV. Check out their free weekend, March 19th and 20th, including these courses: Cisco CCNA 200 through 301, Cisco CyberOps Associate 200 through 201, and many others. Learn and get certified in IT in a way that works with your schedule and is entertaining at the same time. IT Pro TV has 7 studios that are filming Monday through Friday, and those courses get from the studio to their course library in 24 hours. They make sure you're prepared for your exams with their virtual labs and practice tests, too. You don't want to miss the 2 free webinars that are happening in March for IT Pro TV either. On March 10th at 2 o'clock p.m. Eastern Time, the webinar Avoid Cisco Exam Traps, the 3 most difficult CCNA objectives, will be hosted by Wes Bryan. And then on March 24th, you could check out the Cisco NAAS webinar starring Anthony Sequeira. And don't forget, your IT team can level up and enjoy the journey at the same time. Check out an IT Pro TV business plan for your team today. Visit itpro.tv/twit for an additional 30% off all consumer subscriptions for the lifetime of your active subscription when you use code TWIT30. That's itpro.tv/twit and use code TWIT30 for an additional 30% off the lifetime of your active subscription. IT Pro TV. Build or expand your IT career and enjoy the journey. And we're back with atomic rockets, because atomic rockets are cool. And if you grew up when I did, all rockets were pretty much atomic, because when you went to the theater on the weekends to see the god-awful black and white movies of the terrible effects from the 1950s, everything was atomic, because atomic was awesome. And that was back in the age. What was that phrase that Eisenhower used? Atoms for peace. That was it. It was after the atomic bombs on Japan, which was a very bad time, and we were trying to clean up our image. So atomic rockets, if you ever read pulp science fiction or anything, are kind of a cool thing, but they're also real. So that's what we're going to talk about. And by the way, just a quick program note, we were going to include Project Orion in this discussion, which was a gigantic spacecraft designed in the 50s and 60s to use actual atom bombs for propulsion. And it's a great topic, but we're going to move that to another week, because we're going to come up short on time. So this week, we're going to talk about nuclear thermal propulsion and nuclear power supplies and robotic probes. Now, just a quick note. This was actually hypothesized as early as 1903 that radioactive materials could be used for propulsion. A little later, people thought about it for propulsion in space. And nuclear thermal propulsion in particular has its origins in the United Kingdom, as far as I could see, about 1947, that it was theoretically doable with graphite reactor cores, although at that time not considered technologically feasible. But at Oak Ridge in 1953, Robert Bussard, who we all know from his design of an interstellar probe that we never built, did other work with Consolidated Vultee, a contractor. And there was also some work done, interestingly, at that time by a Chinese physicist. And the Chinese actually were fairly sophisticated in their approach to spaceflight as early as the 50s, but just never had a chance to exercise it due to the political convulsions going on over there. So there's a whole litany of stuff to talk about here in terms of actually propelling rockets at high rates of speed and continuously with atomic energy. But first, let's talk a little bit about RTGs. These are plutonium pellets that are used to generate electricity, primarily for, I think, almost exclusively for robotic spacecraft, although they were used in the Apollo lunar landings. So, hey, take it away, Tariq. This is your area of expertise. Wow me.
Well, RTGs are, it stands for Radioisotope Thermoelectric Generator. And like you suggest, Rod, it's like a slug of plutonium that they put in a chunk surrounded by thermocouples. And as it's nice and warm. And as it releases that radiation that can be converted into power. And we might have, the listeners might have be more familiar with The Martian, that movie, right? With Matt Damon stuck on the red planet. And there's a scene in that, there's a scene in that movie where he drives out into the Martian desert. I guess it's all desert, right? But he drives out there and he digs up a power supply that he needs to survive on Mars. And that's an RTG. Basically, it's this generator that converts heat into electricity. And we've used them for a long time. The first one in space, according to some of my research, was in 1961, which was a U.S. SNAP 3B vehicle, apparently. That was aboard the Navy Transit 4A spacecraft. So that's as early as I was able to find one. But NASA has used them on the Voyager spacecraft. The Cassini spacecraft used one. New Horizons, which went to Pluto and beyond.
Galileo, I think.
That's right. Galileo too used one, and many others. Other satellites between the 60s and there had them too.
And the Soviet Union launched these things like crazy for a while. And just if I might just jump in for a second, they're really simple. Sure. I mean, it's literally you can look it up on Wikipedia. It's a big plug of plutonium that looks kind of like a soup can, glowing red. It's very cool looking, and it's wrapped with heat radiator fins, but also it's got thermocouples in there. Really, all it's doing is sending heat through these dissimilar metals, and they generate electricity, and they can last for a really long time. I think I was mentioning to you the other day, though, I'd done a bunch of interviews with some people at JPL about the Voyager RTGs. And I said, plutonium lasts like 80 years or something. So why is it that these generators don't last that long? And apparently, over time, these metal sheets that are used for the electrical generation begin growing little filaments, like little fingers or hairs of metal towards each other. And when one of these metal sheets contacts or connects with another one, it starts creating a local short, and eventually, I guess, they generate less power over time. But that said, Voyagers are going for 42 years now, I think, 43?
Yeah, and it's still out there. Even the Pioneer spacecraft, we're sending beeps back. Yeah. So they really have a lot of versatility. And in fact, we've got two giant cars on Mars right now, Curiosity and Perseverance. And they have a bit of a I don't know if I should say, they have like a caboose on them, if you will. And that is the RTG that they've got sticking up off the back end. And you can see the fins nestled in all of the hardware there too. And that is what has allowed them to drive for Curiosity's standpoint for almost 10 years now, when it was really originally a 2-year mission. So who knows how long they'll be able to keep going when we see how long-lived Voyager has been, how long Cassini, could have been if they wanted to keep it up there around Saturn instead of protect the icy moons there, and how long New Horizons might last, as it's often headed out of the solar system there too. So they do seem they have had their uses, but it hasn't been without issue. When these missions have launched, there has always been a bit of discomfort with some groups because they've been worried about the material, falling back to Earth or contaminating places if something goes wrong with the mission. There have been accidents in the past where these RTGs have the missions have failed. The satellites crashed into the ocean off of the Florida coast or California coast, and they've been able to go back and find the capsule with the RTG in it and recover it from the ocean. So they do build them pretty hardy. So.
And it is worth mentioning, at least on the U.S. side, that they have, I think they were metal, now they're ceramic casks that these things are put in that have been tested to death. They survive reentry, they survive ocean impacts. There's a lot of concern, I think we both remember, around Cassini and some of these other launches about, oh my God, you're sending plutonium up in the atmosphere. What happens if the rocket explodes? We're all going to be poisoned and lose our hair and, look like that woman for the first Star Trek movie. But the truth of it is, they'll survive the impact unless something goes really, really wrong. And they can be fished out of the ocean. And if they're not, they're still going to be good for, I can't remember, I think it's 10,000 years or something estimated that they can sit down there. So while plutonium's not a good thing to have loose in nature like that, at least not that type, they're fairly safe. And they're just so useful up there. I mean, there's no other way you can power something at the edge of the solar system or beyond for decades without having nuclear energy. And they're really very handy. And as I mentioned when we were starting, it's not just robotic probes. It's not talked about a lot, but in the Apollo lunar landing program, Apollo 11 landed. Each of the surface landing missions had a scientific package they left on the surface of the moon. So they had a seismometer and radiation detector and other stuff that sat there on the moon, and they left it behind. And it would transmit information back to Earth. Well, they needed that to be powered. So the first one had batteries, but after that, I think more for the sake of space than anything else, because they could have probably used solar panels. Although I suppose they would have ended up losing. They wouldn't have been able to heat the equipment in the lunar night, so maybe that's why. Anyway, they used plutonium plugs, and I remember very clearly watching Apollo 12, which, if you've ever seen the footage from that, became a radio show very quickly after they got out of the lunar module because the camera got burned out by panning past the sun. But I remember listening to Pete Conrad and Al Bean going back and forth. And I keep hearing Conrad laughing, saying, here's the universal tool, hit that sucker, whack, whack, whack. What are they? And I realized later they had a plutonium fuel rod inside a cask on the side of the lunar module that they had to pull out and stick into this experimental package called ALSEP. And it wasn't coming out. So in true Pete Conrad fashion, for anybody here who's a Pete Conrad fan from the space age, they just started hitting it with a hammer to try and get it loosened up, because at that point they figured, if the case cracks, it's not going to be in there long anyway. So very practical. Those were the days when spaceflight was very much something that should have been done with a cowboy hat on.
Yeah.
So we've used them in human spaceflight too.
I was going to say, there is one RTG from Apollo 13 that I did read in my research is actually at the bottom of the ocean because they never landed on the moon and had to jettison all of that stuff before they came back to Earth. So at least one of those made the round trip, it seems like.
Oh, that's true, because that's right. They brought the lunar module all the way back to Earth orbit. Mm-hmm. Mm-hmm. So nice little bit of trivia. So maybe now you've let the cat out of the bag. You're going to get the NASA cops are going to show up at your door in a few minutes. See that black Suburban pulling up?
Or maybe Jeff Bezos will go look for it like he did for those Apollo engines that he went and fished out of the sea, right?
Those F1 engines.
I did read something interesting too about RTGs, but not in space. And this is from the early, the space race. And you mentioned that the Soviet Union built a lot of RTGs for their satellites. I did read that they built over 1,000 to use in really remote places too, to power lighthouses and other types of things there. So there were other uses that wasn't just in space that these are being developed for. And I thought that we might want to point that out there too.
And just to add to that note, a lot of them are still sitting there, no longer being officially maintained. So there are places where these reactors are just sitting around corroding away, and you don't want to go near them. So if you think you smell radioactivity in the air and you're up in the high, Baltic or something, turn around and go the other way.
Can you smell radioactivity?
Well, who carries a Geiger counter, right?
That's right.
But, if your watch starts glowing or something. So, and there's been problems with this primarily in the supply of the material that we need, right? Because we ran out of plutonium for a while.
So after Cassini, or actually after the Curiosity mission, that was kind of it. NASA could not plan at that time big missions out into the outer solar system and whatnot, because they were literally running out of the plutonium that they needed for the RTGs. Now, around the mid last decade, 2015 or so, if I recall, there was an agreement struck between NASA and the Department of Energy to start actually making the stuff again, to be able to look for new big missions, and so that's these RTGs were assessed for the Europa Clipper mission. I think they're going with solar panels for that one. They just started building it. NASA announced today.
Yeah, I saw that.
But the goal was to have this pipeline now. So for a good half decade or more, there was nothing on the horizon that NASA thought they'd be able to get access to, because it was they use it for national uses first, government uses first, before looking to civilian spaceflight. Now that pipeline is flowing, it takes a while to build up, and they can assess it and consider it for these future missions. And there's a Europa orbiter that might come back, and that we could find new life there. NASA's been looking at missions to Neptune and to Uranus. These could be helpful, because the further you get away from the sun, the harder it is to generate the power you need. The Juno mission, which is closer than it's Jupiter, uses the biggest solar panels we've ever set in space, and it's the size of like a semi truck. And the further you get from the sun, you need things bigger than that and much more capable.
And I was looking up some of this morning, and I just want to remind people that you can find a lot of this information by going to space.com, the premier source for all things space. And nobody paid me to do that. It's just because I'm a nice guy and I'm a big fan.
And a good friend.
Thank you. You too. Let's take a quick break. This episode of This Week in Space is brought to you by Blue Land. Did you know that an estimated 5 billion plastic hand soap and cleaning bottles are thrown away each year? And if that's not bad enough, each bottle can be made of more than 90% water. That is a serious lose-lose situation for this planet. Now, I've interviewed a lot of astronauts over the years, and all these people who come back from space are transformed to some degree by what they see. It's called the overview effect. You see this planet from space, and you see a fragile world with a thin atmosphere and a surface that's just begging for help. And that's something that Blue Land can help do. Plastic has been found in 100% of marine turtles, 59% of whales, 36% of seals, and 40% of the seabird species examined. By 2050, scientists predict that the ocean will contain more plastic by weight than fish. So let's start creating a cleaner planet from home. Blue Land's idea is simple, and it's beautiful. Buy the bottle once, refill it forever. No more plastic waste. The only thing you need to discard is your outdated idea that eco-friendly products are more expensive and less effective. Just fill Blue Land's beautiful Instagrammable bottles with warm water. Pop in one of the hand soap or spray cleaner tablets, and within minutes, you'll have powerful cleaning products in the most incredible scents, such as iris agave, perrine lemon, and lavender eucalyptus. From their best-selling Clean Essentials kit to their hand soap duo and plastic-free laundry and dishwasher tablets, Blue Land has something for every inch of your home. And backed by popular demand is Blue Land's Toilet Tablet Cleaner. Get it before it sells out again. Blue Land's stunning, high-quality Forever bottles start at just $10 when you buy a kit and are meant to be reused forever with money-saving refill tablets that start at just $2. Try Blue Land today. You'll love it, and the planet will thank you. Right now, you can get 20% off your first order when you go to blueland.com/space. That's 20% off your first order of any Blue Land products at blueland.com/space. That's blueland.com/space. I want to transition to nuclear thermal propulsion because it's a really exciting area. So there's been a lot of work done on this that isn't necessarily as well known as it could be. And I think the hardcore space fans know about it, but a lot of folks don't realize we started designing and building atomic rocket engines in the 1950s. And
I was surprised by this too.
Yeah. Project Rover was one of them that started in 1955. That was originally for an ICBM upper stage by the Air Force, because why not power it with an atomic engine? But it was later transferred to NASA and absorbed into Project Nerva, which was very cool, 1958. So Nerva ran until 73, I think. And Nerva was basically a nuclear fission reactor with a hydrogen tank attached to it, and you blew hydrogen through it, and it heats up really fast and comes out the other end very hot, somewhat radioactive, and with a lot of propulsion. And it's interesting because it's actually easier to build a nuclear rocket than it is to build a nuclear reactor, because a nuclear rocket's got a big hole in the side. So a lot of the heat and the pressure just goes flying out the far end. You don't need all those fancy safety protocols and shielding because it's going to be operating in space. So a number of contracts were let by the military and then NASA, and they built a couple of these, and they had this testing ground in an area out in Nevada called Jackass Flats, which I think is a perfect name for a place you're going to pollute with radioactivity.
Well, I love these names just in general. You've got Project Rover and Nerva. That just sounds like a supervillain organization.
Yeah, it does.
But it's just nuclear engine for
right?
rocket. Yeah, it's just nuclear engine for rocket vehicle applications. That's it. So
by the early tests were, how many seconds can we get this thing to run? And, when you compare these to chemical rocket engines, and you're talking about ISP, which is specific impulse, how you measure thrust. Saturn V's ISP, for instance, it was about 263, depending on how you're measuring it. And the longest the rocket engines ever ran in the Apollo program were a matter of minutes. And I think the maximum at least in the West, I don't know about the Russians, but in the West, I think the maximum any rocket engine has been tested is something shy of 8 or 10 minutes. Atomic engines could run for hours. It's like idling a diesel engine in a fire truck, right? They just kind of lope along, and they have specific impulse. There's a number of different levels, but what they were aiming for was between 800 and 900, and Nerva got there. And this was a rocket engine that ran in 1964. A Kiwi engine ran for 2.5 minutes. By the time they got done testing Nerva in the early 70s, they had run it an hour and a half.
Wow.
At that,
can you imagine
power,
like an engine,
right?
An engine just running for that long?
Well, and an atomic rocket engine, right? Yeah. So this was very promising, but by the early 70s, we had Earth Day in 1968. We had the big blue marble picture of the Earth rise over the moon, come back from Apollo 8. There was this growing awareness of environmentalism and, the dangers of what we thought we were doing to Earth, which we probably should have listened to a little more now that we're looking back in reflection. And so between that and the decline of support for human spaceflight after Apollo, this whole program got canceled, and the stuff was done away with, and the hardware. And everything went into file cabinets, and there it sat until as far as I can see, about 2016, when Marshall Space Flight Center and NASA started working with Aerojet Rocketdyne, who were part of the Nerva program, and quietly said, "Hey, let's reinvestigate this." So they're working on it again, which is with the Department of Energy. So we may have a chance to finally start using this. And this would cut transit times to Mars by as much as possibly 50%. And they're looking at using, because of the concerns around, proliferation of radioactive materials and so forth, something called HALEU, which is high assay low enriched uranium. SA, however it's pronounced, which is enriched up to 20%. Uranium in reactors is enriched less than that. But, it's got a lot of advantages. There's less mass required. And this stuff can run for years. So if you're talking about going out to Mars and beyond, I mean, what makes more sense?
Yeah, I like to call it Hallyu. I think that's how you pronounce it. Right? I think, Hallyu.
I don't know. It's either that
I don't know. How are you doing?
You got me back.
But no, it really does seem like there's a much more there's more of an appetite to pursue these things, because trying to get to Mars fast, trying to get anywhere fast, is one of the keys to fulfilling a lot of the exploration goals that we're seeing NASA have and some of its partners. Because one of the things that I've learned in the last 20 years is if you can't get a mission off the ground in the administration that you're in, you're probably not going to get it off the ground if it's going to take people to someplace that's other than low Earth orbit. And this would be something that really could address that. And we've seen NASA, say they're gonna really push this through time and again. It's just been so long that it gets dropped over time. How many space planes, Rod, have you seen get off the drawing board and then fall off the planet? So
well, and how many of the Mars reference mission architecture plans have you seen go by? I know there's been at least 5, and these are major
3 of those
studies
on my shelf. Yeah,
and they go on for years, and they're expensive considering that it's a mission performed entirely on paper or now in computer software. And this stuff studied, and then canceled and renewed and canceled. And it's really frustrating watching it over decades. So just a few more comments on this study that Aerojet's been working on. So we could talk about this for hours, but we can't. So we'll just hit some high points. But I was looking at a presentation by Tim Kokan, who is presenting for the Space Q podcast, which has some good stuff on it if you want to check it out. It's called Space Q. And they're talking about using megawatt class reactors, which are smaller than some that were considered in the past, but big enough. Cryogenic hydrogen as fuel. Their goal, as I was mentioning earlier, is 900 seconds of ISP. Current goal, but that's triple what the Saturn V was putting out, so that's pretty good for a Mars mission. And there's a longer conversation about, do you do a conjunction class, do you do an opposition class, because one's short stay, one's long stay. I think the short stay is 30 days, the long stay is on the order of 450 or something, having to do with the orbit of the Earth and Mars and when you can go back and forth and how. One consideration is, how long do you want to keep these people in space, right? Because going to Mars is pretty dangerous. And the great thing about atomic rockets is that they can go there faster, so you don't end up being a bunch of baked potatoes when you get there, because no matter how much shielding you use, there's still risk. Once you're on Mars, presumably you can bury if you have designed it properly and you pre-position cargo and so forth. If you're going to stay there a long time, you could bury your habitat under sandbags or put it in a cave or whatever you're going to do and protect yourself. But that transit time is a real problem. So
2 years, a 2-year mission is kind of what they were looking at, just like a baseline with the earlier architectures. And you don't get to spend that much time on the surface, for some of those plans. So narrowing that down with, to even a year would be amazing, let alone something much, much faster than that. And you'd get a bigger appetite for people really wanting to go and wanting to support it when they see that kind of a technology that can really turn things around on a like an accessible scale, I should say.
Yeah. Well, and repeatable and affordable. So I've heard estimates by people like Pascal Lee that they thought that the Boots on Mars program would be looking at as much as $1 trillion, and it would be small numbers of people. It would be a sortie, an expedition sort of thing, which is, it's hard to talk about that in the same universe where Elon Musk is talking about, I'm going to send 1 million people to Mars because we'll be flying 10,000 starships an hour and that kind of stuff. I'm exaggerating here. But just to bring it back into the realm of what the NASA Aerojet Rocketdyne study is looking at, they're talking about First crewed mission would be short stay, even though it's a more challenging trajectory to fly. Later missions would be long stay. So they're looking at, and these dates, as you pointed out, are extremely fluid, but they're talking about a first uncrewed mission, a flyby test. So it's just going out to Mars, swinging past it and coming home in 2033. 2037, a short stay that includes a 2035 pre-positioning cargo flight. 2041 long stay and a 2045 long stay. And we're talking about crews of 4, of which 2 would go to the surface for the short stay and all would go to the surface for the long stay. But just to put a point on this, so for an example, that second mission, which is the first crewed flight, it would take 2 SLS launches for the crew, not sure why, 5 SLS launches for cargo, 22 launches of SpaceX's Starship for fuel, and possibly New Glenn launches for cargo hauling. So, and as you go along, those numbers go down because there's a lot of pre-positioning of materials both on Mars and in orbit. But I mean, that's a lot. And when you think about that versus the promise, at least what we've been told with just using Starship, it's kind of a weird hybrid. And I'm not sure how much of it is absolute necessity to accommodate using nuclear engines on rockets, and how much of it's, when you're dealing with traditional contractors, you've got a different way of doing business.
I should point out that one SLS mission is supposed to cost $4.1 billion. So just for one. And
is that the latest price estimate?
That's the latest price. So that's $4.1 billion from the NASA bean counter, the assessors there. And so that's you're looking at $8 billion already just for that, plus 22 Starship launches. That is a lot. So, but you can reuse these. That's the plan for these Starships. So they're designed for that, and they're going to need to do multiple ones just to get to the moon, according to Elon Musk too. So they'll get some practice. I'll just point out that this long stay target in 2040s is once again 20 years out from today, which is what we've been told for the last 60 years, that we're 20 years away from Mars. So
how many administrations is that? Let's count them. I guess it'll take 2 hands. And they've been saying Mars in 20 to 30 years since I can remember, since the late 60s, because these plans started within NASA formally in the mid 60s. But before that, Werner von Braun wrote his seminal book, The Mars Project, or Das Mars Project, that was published in 1951 in German and 53 in English. And that laid out the first real fully worked out, studied plan for sending a number of ships, chemically propelled in this case, to Mars. And, they were going to land with gliders because they didn't know the air was as thin as it was. And they were going to land at the North Pole, and then they were going to drive down to the equator and build more landing pads. And these things these winged gliders were supposed to come in and land on skis. And I mean, it was crazy. But at least he had made the effort, and it was all going to be 30 years out. And that date has just been moving out further and further every decade since then. So, I hope they can do this. I mean, it's a huge program when you're talking about a total of 12 crew members over the campaign or something. But, that's just one example of what you could do if you start working with atomic rockets. But, it really, if it's done right, it opens up the solar system in a big way.
It does, and you could expect that once they get to Mars or to the moon, that they would use nuclear power to power their bases too. We didn't talk much about kilopower, but that's a.
Yeah, why don't you go ahead and wrap up this segment with kilopower, because I'd like to hear a little bit about that. We've just got a few minutes. This is just a little bit closer to now, but NASA recently completed a study called Kilopower, where they really wanted to know, could you put a nuclear reactor on the moon for a base? They wanted to know what it would take to get all of those materials that you would need hardened for space travel, and basically build a 10 kilowatt reactor, one basically that could power a few, maybe like 4 or 5 houses on the moon, and that would be like one little module. You'd need maybe 4 of them to power like a big outpost, a permanent outpost. And so they started that in 2016. They started looking at it. They launched different parts, and they called it, and this is really funny, they called it crusty.
and I'm trying to see if I can find. Yeah, I know.
Bring up a graphic of Krusty the Clown, will you?
And I'm gonna get this. I'm gonna get this wrong. Oh, pardon me. Here it is. Krusty. Kilopower reactor using Starlink technology. That's the Starlink heat pumps that they were using, these titanium pipes to basically get the water heated through the fission reactor, so that they could use then that to drive the actual power plant. And in March 2018, they actually did end up running this prototype reactor for about 28 hours on the ground, not in space. But they had tested a lot of the components of it in space environments, either on short launches, with suborbital flights or other commercial trips. So they know that it'll work, and they know that they could do it. And that's the kind of system that you could see they would have to take this obviously with them, or if it's a one-way trip, like Elon Musk has often said, they could cannibalize their fission reactors from their rockets to build these systems on Mars, and that would be kind of the next big compact power plant that would power humanity on other worlds. NASA's really looking at that. They've shelved it for now because they don't have a way to get this big system to the moon, but they might with Starship, like you mentioned. That's their big ticket. It's Elon Musk's big ticket too. And so if NASA can't do it, one of these private companies that really wants to get there so they can sell stuff or take people and sell trips will figure out a way to do it and use it to bring all the amenities that those space tourists would want.
Well, and there's a couple working on it, and that's pretty exciting, but we're going to have to talk about that later because we're heading in for splashdown. So next week, we're going to come back to you with an installment I like to call You, the Rocket Man or Rocket Woman, and we'll be talking about rocketry that normal people get to do because it's a lot of fun, very interesting, and often nearly tragically hilarious. But before we go, I wanted to touch back on what's happening with the U.S. and Russia in space. So, Tariq, where are we looking at with continued space station operations? Because, that's the elephant in the room, right? We've got Russians and Americans working together in orbit on the space station now. We've got mission controls that are supposed to be coordinating with each other, and as far as we know, they are. And yet we've got this verging on white-hot situation on the ground between these two countries. So how do we keep a barrier between those things?
Well, right now, despite what Dmitry Rogozin has said on Twitter, with a lot of the complaining about the international agreements that Russia and the United States and all of their partners, the European Space Agency, Japan, Canada, the operations on the International Space Station are going as they always have been. So there's Americans in Russia helping shepherd the space station. There's Russians at the Johnson Space Center doing the same. Astronauts and cosmonauts are training for future missions. We do got some live things coming up. We've got two American spacewalks coming up later this month to work on the exterior of the space station. They're adding some new solar arrays. It's a project that's been going on that are more efficient, and that this work will help support that as well as some other preps. But we also have an all Russian Soyuz launch coming up around mid-month. That'll be a new crew that's going to go to the station, and so that'll be something to watch to see how that goes. We expect it's going to go smoothly because both Russia and NASA are committed to stable operations of the station. And then coming back at the end of the month will be NASA astronaut Mark Vande Hei, as well as two other Russians on a Soyuz vehicle. And that's one that we're watching to make sure that everything goes well, because again, Russia has said that that they're going to bring him back just fine. NASA is fine having him come back on a Soyuz mission. Mark Vande Hei will have set a new record for the longest single space flight by an American by the end of this, nearly a full year, much closer than the last two flights by astronauts. So, and if that gets delayed, if it gets pushed into April, it'll be a full calendar year. So those are kind of the next big things that are coming up to watch for and see how smoothly things go. We hope they go smoothly. We hope things cool down. I think everywhere so that we can take a breath. But in terms of like everything going on for space, that's what we're going to be looking for over the next few weeks.
All right. Well, thanks for bringing us up to date. We'll keep an eye on that, and I'll try and keep myself calm until I see you next Friday. And I think at some point we'll exchange hats. I'm going to send you an Ad Astra hat, and you have to send me your space.com hat so we can represent. So I want to thank everybody for listening. If you want to send us feedback, good, bad, and different, you can send it to twis@twit.tv. New episodes of this podcast publish every Friday on your favorite podcatcher, so make sure to subscribe and tell your friends. You can head over to our website at twit.tv/TWIS. If you want to catch the 5 beta episodes of this show, you can join Club Twit for just $7 a month. You'll get all of our podcasts ad-free, including this one, and access to our exclusive Discord channel. Go to twit.tv/clubtwit. You can follow the Twit Tech Podcast Network at Twit on Twitter and on Facebook, and twit.tv on Instagram. By now, you certainly want to know more about Tariq and myself. So if you want to learn about Tariq, where can they go, my friend?
Well, they can find all the new things in space at space.com, but I'm also on Twitter at Tariq J. Malik. And that's where I do all of my posting there too, for the most part. So that's where you can find us. And you can find us at space.com too, on Twitter at space.com and Facebook and Instagram.
Wow, that's a lot. Okay, all I've got for me, if you want to know more, is my website, which I need to update, which is pilebooks.com. That's pilebooks.com. And I spend a lot of time on Facebook under my own name. So hopefully we'll see you at one of those locations. See you next week.